Okay guys, just in case anybody's kind of stuck on how to get started here. So the first step is always to draw that heating curve of water. Okay, looks like this. Remember that the flat spots, those happen at 0 degrees Celsius and again at 100, so the freezing point and boiling point of water. On this one here, again, as we want to on all of them, we want to mark our starting point and our ending point. Our starting point is steam at 130, and this time we're cooling instead of heating. It's exactly the same process. Okay, so I start at 130 and I'm going down to 30, which would be right there. Okay, how many steps am I looking at? 3. Okay. First, I have to cool the steam down to 100. Then I have to condense the steam, and then I have to cool the water. All right, so think about what formulas you need to use at each of those 3 points. Okay, I'll give you a few more minutes. So it's always a good idea to talk ourselves through a problem like this so we know what formulas are appropriate at which steps. Right? In this first step here, I have to reduce the temperature of the steam from 130 to 100 degrees Celsius. Right? If I'm changing the temperature of the steam, what formula should I use for that step? E equals MC delta T. Yeah, I should use this one that actually has change in temperature in it. All right, I've got all the numbers here. It's 150 grams, and it's initially steam, which I can look up the specific heat capacity of. All right, so I'm going to have 150 grams times 2.02 joules per gram degree Celsius. That's the specific heat of steam. And I'm cooling the steam by 30 degrees Celsius. Okay, so in that one there, we are going to have 150 times 2.02 times 30 degrees. All right, so we're looking at 9,090 joules. At the end of that step, I have steam at 100 degrees. Okay? I'm going to continue to reduce its energy or try to cool it. It's going to condense back into liquid water during this step. There's no temperature change during step 2. So what formula should I use? E equals MLV, yeah, because this is vaporization and condensation. Okay, so E equals MLV for that one. Okay, 150 times 2,260 joules. All right, so 150 times 2260. All right, so we're looking at 339,000 joules. All right, after that step, I have liquid water, at 100 degrees. I need to get it down to 30. Okay, so again, I'm changing the temperature of the water from 100 down to 30. What formula should I use for that step?
MC delta T.
MC delta T, yep. Okay, I'm changing the temperature. Okay, and this time I'm going to use the specific heat capacity of liquid water, 4.2. And I'm changing the temperature by 70 degrees from 100 to 30. Okay, so when I punch in those numbers, 150 times 4.2 times 70, all right, I get 44,100 joules. Okay, what do I do with those 3 numbers?
Add them.
Add them up. That'll give me the total energy, this time lost by the steam, in order to get down to water at 30 degrees Celsius. Okay, so take that number, add that number, and add that number. We are looking at 392,190 joules. Okay. All right, everybody all right with that one? Are these ones also very patterned? Do I do the same thing every single time? Okay, so as long as I learn those steps, I know what formula do I use on each part of the graph, I'm pretty much set on these questions. Okay, now, that means you do have to memorize that on this part of the graph I use this one, and on this part of the graph I use this one. Okay, but once you're there, it's just a matter of plugging the numbers in. All right, give number 11 a try here. That's as big as they get, number 11. That might be a hint to the number of steps. Oh, and how many grams is 0.08 kilograms? 80, yeah, so you got your mass there. On a test, I won't give it in kilograms. Okay, let's have a look at this one. So we're converting ice at -40, okay, into steam at 160. So this is a big change, right? So if we draw our heating curve, okay, we're starting at -40, which would basically be the bottom of the curve, right, way down in there. And we're going for 160, which would basically be the top of the curve. So my first step is going to involve heating ice from -40 to 0. I have to heat it up to 0 before it's going to melt. All right, so that'll be step 1. What formula will I use for step 1? MC delta T, yeah. Okay, and they tell me I have 80 grams of ice, and ice has a specific heat of 2.116, and I'm changing the temperature by 40 degrees Celsius. All right, so that first step, 80 times 2.116 times 40. All right, so we're looking at 6771.2 joules. All right. After step 1, I have ice at 0 degrees Celsius. If I keep adding heat, what's the ice going to do? What does ice typically do at 0? Other way around. Water will freeze at 0, ice will melt at 0. Right? Okay? And that means then that at that stage, I'm going to have to use this formula because I don't have any temperature change. It stays at 0 the entire time. So I have to use E equals MLF, right? Where LF is the latent heat of fusion, the value of which is on your formula sheet is 333 joules per gram. So step 2, melt the ice. E equals MLF. 80 grams times 333 joules per gram. All right, so we're looking at 26,640 joules. Okay. After step 2, I have water at 0 degrees. If I keep adding heat to it, what's going to happen to it? The temperature is going to go up. Yeah. By how much? 100 degrees. It's going to go from 0 to 100 if I keep heating it. All right, so that'll be step 3. I'm going to change the temperature of the water. So that'll be E equals MC delta T. Still 80 grams, but now it's liquid water. So I use the specific heat capacity of liquid water. And I multiply by 100 degrees Celsius. Okay, 33,600 joules. All right, after step 3, I have water at 100 degrees Celsius. What does water do at 100 degrees Celsius? It boils and turns into a steam or a vapor. Okay, so in that case then, there'll be no temperature change, so I'll have to use E equals M times the latent heat of vaporization. All right, so that'll be step 4. Okay, 80 grams times 2,260 joules per gram, the LV per water. All right, so we're looking at 180,800 joules. Okay, after that step, I have steam at 100 degrees Celsius. If I keep adding energy to it, the steam will get hotter. I'm going to change the temperature of the steam in step 5. Anywhere where I'm changing temperature, I use the formula that has change in temperature. E equals MC delta T. All right, that's 80 grams times now the specific heat capacity of steam, which is 2.02, and times the change in temperature, which is going to be 60 degrees because I'm going to 160. All right, so take my numbers there. 80 times 2.02 times 60, right? Whoop, I put a minus in there. 80 times 2.02 times 60. That's better. 9696. Okay, what do I do with those numbers? Add them up, yeah, that'll be my total energy. It's gonna be a lot, okay, and when I add them all together, 250,507.2 joules worth of energy. Okay, again, that's as involved as they get. Having 5 steps isn't any harder than having 2 steps, okay? It's just, you have to do more steps, right? But you never have to manipulate, you just have to know anywhere where the line is diagonal, it's MC delta T. It's flat and at 0, okay, you're talking about melting or freezing, you're using E equals MLF. And if you're at 100, talking about vaporizing or condensing, then you're using E equals MLV. Okay? All right, I would like you guys to try one more here. And I think number 1 is the right one. Okay, because it's very much like what you'll get on your unit exam. Okay, so just try number 1, don't worry about the others, and then we'll see where we're at. So this is exactly like what you're going to get on your unit exam. How many steps is it? 3. Okay, so if we're drawing our heating curve here, okay, there's below 0, there's between 0 and 100, there's boiling, there's above boiling. Okay, we are starting with water at 3 degrees Celsius. So we're starting basically right there, and we're going to steam at 115. So we're going to right there. So the first step is heat the water to its boiling point. Okay, that would mean from 3 to 100. So step 1 involves changing the temperature of the water. E equals MC delta T, right? And it's 400 grams, so 400 times 4.2 because it's liquid water times 97 degrees Celsius. I'm only heating it to 100. Okay, water is going to turn to steam after that. Okay, and that has a different heat capacity. So 4.2 times 400 times 97. Right, so we're looking at 162,960 joules. All right, once I'm done that step, I'm here with boiling water. And if I continue to add heat, all of that water will boil off. In other words, it will vaporize. Okay, so that will be step 2. And when I'm vaporizing water, there's no temperature change. So I have to use E equals MLV for the latent heat of vaporization. Right? I take my 400 grams and I multiply it by LV, which is 2,260 joules per gram. Okay, so 904,000 joules. Okay, after that step, I have steam at 100 degrees Celsius and I'm going for 115. So I've got to heat up the steam for step 3. And if I'm heating up the steam, that's going to mean E equals MC delta T, 400 grams of steam times 2.02, the heat capacity of steam, times 15 degrees, because I'm only heating it from 100 to 115. All right, so 400 times 2.02 times 15 is 12,120 joules. Right? Take those 3 numbers and add them together, and I get 1,079,080 joules. Okay? Prime example of what you will get on your unit exam on Tuesday. All right? Questions on these? Okay, so here's the plan. I'm going to start biomes today, so we get a little bit of it done, because it typically takes me a little longer than one class to teach it. Okay? And well, we don't have longer than that on Monday, so I'm going to start it today. We're going to do our unit exam review tomorrow, even though I won't have taught all of the biome stuff by then. Okay? And then on Monday, I will finish off the biomes. Biomes is just memorization. You just have to know this biome has these characteristics and this biome has these characteristics, and be able to match it up with a climate graph. Okay? So it's just memorization. So we'll go over that today and Monday, okay? Review tomorrow, and your test is Tuesday. Okay? Then Wednesday we'll go over the test, review chemistry. Thursday we'll review bio and physics. And then we're done. All right. Give you a little break here for a couple of minutes while I get the bio lesson up. Yep. Okay, so biomes is probably something you remember a little bit from like junior high science. Okay, you talked about like the boreal forest, and you talked about the prairies and the tropical rainforest and stuff like that. And that's the same thing we're gonna do here. We're just gonna go over the, you know, kind of the location of all of those biomes, okay? Maybe a few factors that affect their climate, and what a climate graph for those biomes looks like. Because on your test, the way this is gonna be tested is two ways. There will be some multiple choice questions that will have pictures and descriptions, okay? So it'll be a picture of a biome and then a description of the biome, okay? Use both, don't just look at the picture, because it could be a jerk and take a picture that's a little bit misleading, okay? Make sure that you read the description as well, and then it's like, oh, okay, so, you know, this is a very northerly biome with lots of, you know, spruce trees and sparse rain and, you know, severe winters and blah, blah, blah. The, you know, this biome is A, the tropical rainforest, B, the desert, C, the boreal forest, and D, the Mediterranean climate. Okay, pretty obvious that's the boreal forest, okay? So it could be something like that, okay? The other way is in the written response. And in the written response, it'll be like this. Here's a climatogram, here's a climate graph. Tell me which biome it's from and why. Okay, what I'd be looking for in that question is this. The first 2 marks would be for your interpretation of the climate graph. So you would tell me, you know, based on the temperature pattern, this you know, climate graph is probably from a place near the equator because the temperature doesn't change very much. And according to the precipitation bars on this climatogram, this climate is very dry, okay, because the bars are all very low. Because of this seems to fit with the equatorial desert biome, because equatorial deserts obviously have no temperature change and very little precipitation, so these two things go together. It'd be a 5-mark question, 2 marks for your interpretation of the climatogram, and 3 marks for identifying the biome and telling me why it fits with that. Okay, everybody with me on that? Now, in your notes, you don't have pictures of the climate graphs. My notes, there are. So it's not a bad idea to take pictures. I'll stand to the side and take pictures of what the climate graphs for each one look like to help you study for those questions. Okay. All right, so these are the locations of the biomes of the world, right, where each one is. Okay, so if we're looking at these, okay, we can see that you know, our first one here is the tundra. The tundra is a very northern biome, right? Tundra actually means treeless. So this is an area that gets very long, very severe winters, okay? The soil doesn't even completely thaw, okay, in the summertime, okay? So you're only gonna find them in the very far northern parts of Russia. This would be like Siberia, okay? And obviously Greenland, right? And you would have, you know, lots of northern Canada, and I mean, probably on the peaks of some of the Rockies, probably on the peaks of some of the Himalayas as well. We could say that that would also be a tundra biome, because above the tree line in the mountains is tundra. It's alpine tundra instead of Arctic tundra. Okay? They look very similar because the fact that it's there is based on temperature. And obviously the higher up you go, altitude being a factor affecting climate, okay, the colder it's going to get. Okay? Second one here, the taiga, the boreal forest. So much of Canada is taiga, right? If you go north of Edmonton, like if you've been to Fort McMurray, you've been in the taiga, okay? Mountains are usually also considered to be taiga. They're basically the same kind of thing. It's just caused by altitude instead of latitude, right? But it's the same types of plants that would be growing there. So this map is a little bit different, but okay, I would say this dark blue and this kind of dark green, they should be the same biome. Okay, we can include mountains and taiga, boreal forest, to be the same biome. right? Temperate forest, that's going to be much of the eastern part of the United States and the southern part of central Canada. Okay? Deciduous means, okay, or temperate deciduous forest means that they lose their leaves. Okay, so this would be like your maple trees and things like that. Okay? Tropical rainforest, so this kind of light greenish color, right? Obviously much of South America would be that color because that would be the Amazon rainforest, lots of Central America, the Caribbean islands, okay? Just a little bit on the Horn of Africa here, okay? Madagascar very much, Southeast Asia, okay? Basically all of Southeast Asia, right? So New Guinea and all of that kind of stuff, right? Would be tropical rainforest, okay? Lots of it. Grasslands. Okay, there's a couple of different names for a grassland. Sometimes we call it prairie, and in Asia they call it steppe. Okay, but it's basically the same thing. It's where we are. Okay? The biome that we live in is the grassland or prairie biome. Right, so you can see that it's the prairie provinces here, most of the central and western United States. Okay, same thing. Most of that is a rain shadow effect. Right, and then you've got a lot of that here through Europe and Central Asia. Okay, lots of grassland in that area, and a bit, okay, through there. Oh, we're missing one on this map. I didn't notice that. It's a brand new map. I didn't notice it's missing savanna. It's got it colored as grassland. Okay, savanna is another one, but savanna is a tropical grassland. Okay, so we're a mid-latitude grassland where we actually have summer and winter. Okay, but you would also have equatorial grassland, which would be the savanna, where you'd have lions and tigers, and not bears, but elephants and giraffes and things like that. Okay, and then temperate rainforest. Okay, you can see a little bit of temperate rainforest here in western Canada, so the coast of BC, where they have the big giant redwoods, okay, the big sequoias. You know, that they can cut a hole in, cars can drive through. Okay, like the really huge stuff. If you've seen Return of the Jedi, where they filmed Endor, that's actually the west coast of Canada. Okay, it's like in Victoria, okay, Vancouver, those areas. So really, really big, tall trees. Okay, desert, obviously. Okay, all of North Africa, the Middle East, lots of Asia. Okay, and that would be hot desert. Right down in here, okay, in northern Mexico and southern United States, so Arizona, Nevada, southern Utah, southern California, okay, Baja, those kind of places are also desert, but they're not equatorial hot desert, they're more mid-latitude cooler desert. Okay, and they've also got Antarctica labeled on here. That would be what we would consider to be extreme desert, rocks and ice. All right, so that's where they're all located, and you can kind of see that there's a bit of a pattern to most of those, right? Like the desert is, you know, kind of in one place, but near the equator we see lots of tropical rainforest. Okay, you go a little bit higher than that, we got lots of desert. You go to that same latitude below the equator, and we're seeing deserts at that latitude as well. Okay, they talked about that the other day when they were looking at the cycling, okay, of the winds. Okay, the Hadley cell where it meets the Ferrel cell is typically a high pressure area. Okay, and it tends to be drier. All right, so let's start the process here. Tropical rainforest. Okay, has anyone ever been to a place where there was a tropical rainforest? Like certain parts of Hawaii, okay, places like that. All right, so the tropical rainforest is very different than a forest in Canada. Okay, in a true tropical rainforest, there are up to 8 different layers of vegetation. Okay, there's like your ground cover, undergrowth, okay, kind of understory, mid-canopy, okay, lower canopy, mid-canopy, upper canopy, like there's just all these different layers to the forest, okay? And the vegetation is so thick that barely any sunlight actually gets all the way to the forest floor, okay? That's why you see different things growing at each level of the jungle, okay? So it's very, very dense, very, very luxuriant vegetation, and it is evergreen. In the tropical rainforest, there is no reason to go dormant because you're going to get your precipitation and warm temperatures all year round. Okay, so that's kind of what it looks like from the top, and you can see there's lots of different kinds of trees as well. You look at a forest in Canada, okay, like we go to Banff, and you're going to see some poplar and some lodgepole pine and some Engelmann spruce and some Douglas fir and some black spruce. Okay. In the tropical rainforest, there are literally hundreds to thousands of different kinds of trees, just the trees. They're not even talking about the undergrowth and all that kind of stuff. Okay, so the diversity is huge. Okay. All right, so how do you get that many plants? You get lots and lots of rain, and you get very regular temperature. So the climate graph looks like this. Take a picture. Okay, in that climate graph, we see that the temperature line is basically unchanged. Okay, it stays at basically the same temperature. Okay, reason for that? It's near the equator. Okay, and near the equator, the amount and intensity of sunshine does not change significantly throughout the year. Okay, there's no distinct seasons. And we can also see that the precipitation bars are also pretty flat. Okay, like the precipitation is about the same all year long as well, and it's high. Okay, their driest month where this was 150 millimeters of rain. So their driest month, they got that much rain in their driest month. We get that in our wettest month. Okay, like this month is supposed to be our wettest month. June's usually our wettest month. We might get around that much. Okay, if it's a normal year. This year we might get less. Right? But that's their driest month. The rest of the time, so they're getting that at least or more every single month. So that's a lot of precipitation. And that's how you get thick, luxuriant vegetation like they have in the rainforest. So like looking down on the top of it, you can't even see the ground. Okay? And you do that in Canada, lots of places you can see the ground. Right? And you can see in this picture here, this is Hawaii. Okay? The mountains are very different from our mountains. No matter how steep the face is, it's got stuff growing on it. Okay, like the mountains in Hawaii look like a chia pet. Okay, the stuff can just grow on every surface. All right, no matter how steep. You don't see that here. If there's a steep cliff, it's bare rock, right? Because there's just not enough regular moisture for anything to be able to get a foothold there. Okay. So very, very different. So we got high temperature, high rainfall, high humidity. Okay, precipitation exceeds evaporation. That means more rain falls than evaporates. That equals frequent what? Flooding. Okay, if you look at like the Amazon, okay, the Amazon rainforest, the Amazon River is flooded basically all the time. Okay, parts of the jungle are almost always underwater. And flooding is frequent and quite regular, normal kind of thing for it to happen. It's why in some places in the jungle, you see people build their houses on stilts. Okay? That way if it floods, they just hook up the boat. Okay? House stays out of the water. All right, so the soil in the tropical rainforest, believe it or not, and this is counterintuitive, the soils in the rainforest are awful. Okay? They hold very little nutrient value. There's almost no topsoil. Most of it is clay. Okay? So how do you get thick trees and forest growing if the soil is so rotten? Think back to what I was just saying about being pretty regular. What's usually happening in the rainforest starts with F. Flooding. Okay? So most of the time, the trees, their roots are underwater. Now, floodwaters are typically pretty dirty, which means they contain a lot of nutrients. Okay? And so the plants are typically getting their nutrients right out of the floodwater. That also, though, contributes to the fact that the soils are very poor. Because when you've got water sitting on top of the dirt becomes saturated. And that means then that any moisture in the soil is going to get, any nutrients in the soil are going to move by diffusion from an area where they're concentrated, the soil, into the water where they're not concentrated. Okay? It's a process called leaching. It's just like it sounds. Literally sucks the nutrients out of the soil. Okay? This is why people have a hard time making agriculture work in the tropical rainforest, where they do slash and burn agriculture. So they cut down a big swath of rainforest, plant a crop, and after 2 years the soil craps out and they can't get anything out of it, okay? Because there's just no nutrients left in it. Okay? So the soils typically look kind of red and bleached, but they're full of roots, obviously, because there's lots of trees everywhere. And the roots are just really there to anchor them. getting their nutrients right out of the water. Okay, so the soil, like we said here, any soil in the tropical rainforest, the A horizon, the topsoil is thin to absent because it usually gets washed away by the floods, okay, so it just doesn't get a chance to collect. The B horizon, that doesn't get washed away, it's clay, it cements itself together, okay? And then the parent material will be quite deep underneath that. All right, vegetation in the tropical rainforest looks like this, okay? So you got ground level, okay? And then you've got the buttress roots, those are the funky looking roots they grow out of them, like I call them a snorkel, okay, back in the biology unit. So you've got your shrub layer, you got your under canopy, you got your main canopy, you got your emergence. You can see there's a whole bunch of different layers in here, okay, to that tropical rainforest. This is what the rainforest looks like at ground level. Okay, very different than a forest in Canada at ground level. Forest in Canada at ground level, you can see quite a ways, right? There's lots of space between the trees, right? There might be the odd rose bush or willow or something that kind of gets in your way, but for the most part, you can walk around pretty easily. In the tropical rainforest, you want to walk around, you best carry a machete. Okay? That's the only way you're A, going to make any forward progress, and B, find your way back. Because if you don't have a path of destruction to follow back, you will get lost. This forest literally just closes in behind you, and everything looks the same. Okay? You can't look up and tell where the sun is because there's too many canopies and layers above you. You can't even find the sun, so you don't know which way is north or south. Okay? In a Canadian forest, how can you tell which way is north or south if you can't see the sun in a Canadian forest?
Isn't it what way the moss grows?
Exactly. Moss only grows on the north side of trees because that side is always shaded by the tree. You didn't know that? Now you do. Okay? You can always tell which way is north by looking for which side of the tree the moss grows on. Okay? Always grows on the north side. Okay? That doesn't work here. Moss grows on every side. Okay? There's water everywhere. Okay? So it's tough to get around. Okay? So as we were saying here, up to 5 different layers, or even sometimes 8. Okay? There are 100 different tree types per hectare. Okay? A hectare is an area 100 meters by 100 meters. So roughly the area enclosed by the running track. Okay? 100 different kinds of trees. Thousands of trees, but 100 different kinds in that space. Okay? As we were saying, in a Canadian forest, you'd be lucky if you had 5 or 6 different kinds of trees, okay, in that same area. So the diversity is very, very high. Okay, the animals that live in the rainforest. Okay, I know they always say that the lion is the king of the jungle, but the lion doesn't live in the jungle. Okay? The lion lives in the savanna, which is not the jungle. Okay? Lions don't live in the jungle because, well, jungles are flooded most of the time. It's very difficult to live at ground level in the jungle because unless you have a snorkel, you're going to be underwater. Okay? That's why there are also very few subterranean animals, that is, animals that burrow and make their home underground. Maybe fish, okay? Because you can't live underground in the rainforest, your hole will be full of water all the time, okay? So it wouldn't really work. All right, so what we do see in the rainforest are lots of arboreal creatures. You can see it almost every
Good afternoon, everybody.
picture here is something
We
in a tree.
are ready for people to make their way outside for